I'm Tara Walker. I'm an AWS technical evangelist for Amazon Web Services. That just means a software engineer that can talk to people. And I have with me Mackenzie. Go ahead and introduce yourself.
I'm Mackenzie, as Tara said. I am the startup evangelist at Amazon. So I work very closely with startups and those organizations.
And today we're here to talk about, that's a huge title, right? So let's just say we're going to talk about microservices on AWS. That's a huge, long title. It'll have all of that and more in it. So just kind of quickly looking at our agenda, we're going to try within a 15-minute period to talk about the evolution of monolithic applications to microservices and obviously what that means for us. And then we're going to talk about the core principles of microservices, approaches to building them. Finally, we're going to get into the architectural principles, which will be hopefully really great because we're going to apply those to how you work within those principles with AWS, and then give you some resources to go further. We're also probably going to stop and do a commercial break for some cool things we have going on this evening as well, right?
So a good thing, just kind of get a little baseline going, is that we've been around since 2006, over 10 years building stuff. And a lot of people to this day still think about AWS as just storage and compute with EC2 and S3. But in the past 10 years, we've launched a lot more. So AWS is everything from streaming analytics with Kinesis, large-scale databases with like Redshift. If you want an Elastic MapReduce cluster, you can do that by just clicking a button. So I mean, if you just look at a slide of how much stuff we offer, it's a lot. It's more than just storage and compute.
You guys can read that, right?
It's available online. You can definitely search it. And it took a lot of time to get here, right? This is 10 years of innovation. If you look at just the pace of how many features and services we release each year, last year we did exactly 722 new services and features. This year, as of September, we're at 706. So we're already setting the pace to surpass that. So there's a lot happening, but you can't do this with a monolithic application. And we kind of want to talk about the history of how we started as a monolith at Amazon and how we started shifting as an organization away from that. I think you'd be really good at kind of diving into that.
I can try.
Go for it.
All right. Okay, so AWS, to get this innovation so quick that you see us pounding out features to you, we literally started off as a monolith. And so we had to migrate to get much more agile, bring you the innovation you need to migrate those kind of production things to a microservice type of architecture. So we started out just like everyone else, like this. And then we went to the fact that, hey, we're doing all this great stuff, but we're really having challenges at scale. And if we're having challenges and these difficulties of scale to get you innovation, that's not going to be great for you all running your services on us. So we found that the typical challenges that you find with monolithic applications: difficult to scale, very long cycle to build, test, restore, everything that you're facing out there, we were facing. And then operations was a nightmare, because if you think about it with monolith, you change one thing and then the dominoes start to fall. And that's exactly what was happening for us at Amazon and Amazon Web Services. So it was who's the owner, who broke this, how do we coordinate this? And that's not great to get you to break things you need out in the world. So we migrated over thinking, okay, this is difficult to scale, maybe we can still tackle this, but we found that even after all of the enhancements we try to make with this monolith, the architecture is still hard to maintain, and we just were not evolving. New releases were still taking months. I mean, like, we tried to optimize this thing to the core. And then every time we wanted to add a new feature, it just took so long. So you see that like in 2008, we were like at only 49. And the reason why we can crank these things up now to 706 in September is we really had to find a better way to do this. And then finally, again, the same challenge you face, when we started to look at trying to get more releases out, we realized we weren't agile. We were not able to move very quickly and respond to things you need. If you know nothing about Amazon and Amazon Web Services, we are really customer obsessed. And so agility is really important to us. To be able to make sure we're accommodating your needs is really essential. So the lack of innovation we had because of this monolith, the agility was a huge problem. And we were doing the one thing we never want to do, frustrating you guys as customers. So if you look at this is the monolith lifecycle. You have all these developers working on all these pieces that will go in this one box. And the delivery pipeline is still the build, test, and release, right? But the problem is all of this build, test, and release is trying to still be squeezed into this monolithic box. And that, again, at any point can cause friction in its life cycle. So if you look, it was one, what's the issue with that? Too much software coupling, typical things. Teams keep depending on other people's libraries, each other's common libraries. So if I break something, then Mackenzie is mad at me and throwing things across the cube. And then, we're blocked and we can't build the software. I can't go forward till he's finished with his part. Too much software coupling. And then thinking about that shared library, then there's the shared data. If I'm depending on your database schema and you make one change to that, so your libraries are pretty consistent, they haven't changed, but now you've changed your database schema. You've changed the data that's necessary to get this library to run. It's a terrible mess. And so instead of us throwing darts across the cube, again, we had to find something called change. And we knew there had to be a better way. So around this time, we implemented a company-wide, the entire company mandate to decompose this monolith and literally devolve that into an ability to evolve into microservices. So we went from this big monolith to literally microservices. So let's define that, because everyone keeps using the word microservices and everyone has all these titles. So we went up and literally looked at what it said on Wikipedia. Yeah, that's a lot of words for something as simple. We just need a really succinct definition for it. And I like the definition that Adrian Kosut has, and now he kind of works for us, so that kind of works out. So he had a really simple, succinct, and just really a keep it simple, stupid kind of definition for it. It's a service-oriented architecture composed of loosely coupled elements that have bounded text. He did a great job at really simplifying that. So if I go back and look at this really quickly, so the services communicate with each other over the network. So again, just service-oriented architecture. We can update these things independently. They are not so coupled and dependent on each other that one thing literally does the domino effect and break others. And then these are self-contained. So again, if you're really going to do microservices, I always keep saying to people when you're going through, self-contained, self-contained. Dependencies should only be around that one microservice, that one functionality. So it shouldn't have to know anything else about the other pieces that are working in this solution. And the key with all of this is do one thing and do it one thing well. So everyone knows about the Swiss Army knife. Yeah, you probably could cut down a tree with this, carve a new Mona Lisa in, the stone and everything else. But is this really the right tool for the right job? So when you have the right tool for the one job, this one tool that does something and it does it well, it is the perfect tool to the job. This is how things work appropriately. So let's you want to get into the anatomy of what a microservice actually is?
Yeah, let's talk about a microservice. So a fun stat is when we were in Amazon back in the early 2000s, the code base itself was just 2 gigabytes of C++. So you think about coming in as a new developer and having to understand every single line that comprises 2 gigabytes. You think about how long it takes to run tests against that. Think about how long before a developer feels confident enough to make any kind of changes. So we started breaking this apart. You think about doing smaller chunks, right? And that's essentially what the microservice is. And with it, you have a cable you step on, and you've got your backend data store. It can be whatever you want. The freedom of a microservice is you can choose the right storage that's right for your service. You're not dependent on other teams' decisions for it. Sitting on top of that, you just have your application logic, right? This is whatever code you want to use. If you want to write that in Java, Node, Scala, it doesn't matter, but you're basically, that's handling all the logic inbound to your microservice. And lastly, you need a way to interface with this. And so there, you're just basically going to have a public access to that through an API. There's no other way that any other team is going to be allowed access to your database. The only way that any other team or any other service is going to have access to this information is through your public API. As soon as people start building and depending on this database, you start building that dependency that starts slowing things down. And if you start building many of these, pretty soon you have other services that are now dependent on this green team. I'm a fan of the yellow team, you might be a fan of the red team. The whole point is no one's talking directly to these databases anymore. As this keeps scaling out, soon you have little components of your application, of your website, whatever it is that as a whole create the full user experience. And you can see this on Amazon's site. So if you shop for a shipping container on Amazon, You can buy one for $15.80 on Prime. But this is all comprised of, is this like a really bad animation of squares popping? It is. So each square here is a microservice within our infrastructure, right? This is a whole separate team that manages customers, people might also be interested in these sponsored links, and a whole separate team deals with like images and customer reviews. And these components can change all throughout the day without any concern or impact on other teams. This is ugly. This is what 2 gigabytes of C++ source probably looks like back in 2000. This is, again, what we started with. When you start breaking this apart, you say, well, at what point do you say we've been successful in migrating? At what point do we say that our organization is now moving quicker and microservices have been successful? And for us, these are stats within Amazon from 2014. They're much higher from now. In 2014, we did 50 million deployments in that year. On average, that's every 0.63 seconds, now, of just new features going out. This would not have been possible if you had to go through gigabytes of code and wait for all these tests to run, wait for the compilation of that code. This is good for not only enterprises, this is how you're going to get that speed going. We see this with a lot of other companies. Gilt's a great example of a company based here in New York. They do flash sales. So at 3 p.m. every day, people flood the site to purchase and buy stuff. What I like about this is if you take a look at their traffic, right? This is when their sale hits. This is when everybody comes and starts buying. The cost of failure for Gilt is exceptionally high at 3 o'clock compared to like 9 o'clock in the morning. If something fails in your infrastructure at any time around here, nowhere nearly as catastrophic as at their flash sale point. And if you're dealing with a monolith and the whole thing just starts falling over, it becomes very difficult. However, if you break this into the smaller pieces, you're able to scale what's important to be handled at this time. You're able to say that in order to, we need to make sure that we have enough shopping cart capability, that the login system works. You can scale those components individually, which then gives you a much more robust and reliable infrastructure. One thing I'm curious about is microservice architectures on AWS, so maybe I can pass this off to you.
We talked about how great they are, right? But how do we do this on Amazon? That's probably really right why you're here. Yeah, this all sounds wonderful, and everyone else has done it, but now how do I do it? So let's talk about some key products, their services that are actually a part of AWS that enable microservices for you. The first one we're going to talk about enables you to have a REST API, a public API. So the first thing you will know about microservices is that your entry point is a REST API. That's how people get into and get data back and forth from you without having that tightly coupled software. So our service for allowing you to build your own custom APIs and having those back end be anything and have that loosely coupled is API Gateway. So you can build, publish, manage, version, etc. APIs for your applications. And that allows you then to break up, you saw the put and get of restaurants to drivers. This is where you would define those things and actually publish your APIs out to the persons that are consuming it. What's also great about API Gateway is if you want to even provide an SDK for these people without having to build an SDK from scratch yourself, we literally support different languages of saying, hey, I really have solidified my API here, publish an SDK for them in this language. So very robust ability to build your API for your microservice.
What about Swagger?
Yeah, you can use Swagger for that as well. So you can actually import your Swagger definitions. If you don't want to use the console, there's various ways to use API Gateway. You can import your Swagger definitions. You can import your JSON definitions of the API gateways, or you can use the CLI or the console to actually build your gateway REST API as well. The next thing we're going to get into is what enables the actual processing. What is the compute power that enables our microservices? And there are 3 different services that will allow you to do this. The first one you guys are probably really familiar with is our core product, EC2. So this is our virtual server in the cloud. You can resize compute capacity, you can scale it. Our typical, this is our core EC2. You can then therefore build your own processing on EC2, create your own VM, standardize your AMIs. The typical greatness that is EC2, that still hasn't gone away, you can do that. The other thing that you can do if you want to use compute, we're in Container Days, so I would be remiss if I didn't talk about ECS. You can actually run and manage your Docker containers and have a infrastructure for your microservices that is serverless using your Docker containers. And so that's another compute mechanism to be able to then enable your processing for your functionality of your microservices. So again, it's no additional charge for this, very high performance, running Docker. If you're excellent at optimizing your Docker containers now, ECS is the tool for you.
Can I add 2 things to this?
Sure.
This
Absolutely.
slide's outdated, so Container Registry is live, but not only do we have Elastic Load Balancer, back in, 6 months ago, we launched the Application Load Balancer. So you think about a load balancer, traditionally you have mywebsite.com, and that has to then have whatever backend clusters or services that that's talking to. Application Load Balancer gives you more granular control. So you can say, mywebsite.com/login goes to this cluster. That cluster could be EC2 or ECS. Then /orders will go to maybe completely different infrastructure, different set of machines to power it.
I hope I have a good graph for that. I think I do.
Hopefully.
Do
I have no idea.
I don't remember. Okay.
But it's a really, I definitely check out Application Load Balancer. It's really, really sweet and it integrates beautifully within our container service offering.
And it's cheaper.
And it's cheaper. We always
Cheap
strive
is
to
good
lower
to
prices
go down.
52 price reductions in the past 10 years.
Yeah, our expansion is your game. The one that is, okay, I'm not gonna say my favorite. The one that I have enjoyed the most, just because of the flexibility, is Lambda. So this allows me to run code in response to events. So I can literally trigger when my microservices will run based upon an event happening. Someone just went and decided to buy this product. They then triggered an S3 bucket to have some storage thing, and my Lambda can kick off my microservices even without human interaction. So a Lambda allows you to just pretty much give us your code, and we run that in response to an event. So this, obviously, being also serverless, is a great compute service for your backends when you're talking about your REST API. So I can now tie API gateway, of course, to EC2, ECS, as Mackenzie said, the greatness that we've come out with that. But then I also can do the same thing with Lambda and just say, hey, when someone requests my REST API, kick off this Lambda function in response to it and give them the information and data back. Again, these are all great services, and you can run your microservice computing power based upon your skill set, your needs, and your desires. So from a microservices perspective, from compute, we have 3 main things there. So EC2, our old standard core, ECS, which again is evolving quickly, and as he talked about all the rapid new advancements we have in that, and then Lambda. So those are your compute powers for your microservice. That's what powers your microservice. And then obviously you need to have a place to store your data. There's lots of places at Amazon Web Services you can store your data. Obviously we have RDS and Aurora and Redshift and lots of places. But what we find that scales very quickly with great reliability for you to change and give you that agility that you need with microservices is a NoSQL database. And for us, for that is DynamoDB. Now, the great thing about microservices is you are not locked into any database. So that means one microservice can write to DynamoDB, one microservice can write to RDS, which is running Oracle or SQL Server or anything else. I can have another microservices that decides, hey, I don't want to do any of that. I actually want to run this directly against my Redshift. You have the ability with microservices, that's the whole point of agility, to have your storage options be just as varied as your compute options. And so the one that we're going to feature here, but is not just relegated to it, is DynamoDB. Again, it's our NoSQL data store. So let's look at what a microservices architecture actually looks like. And again, remember, the whole trick of microservices is that you use the right tool for the right job. So you can have clients coming in from your mobile apps, from websites, from other services that are being triggered. And then that can go through, obviously, the internet to your REST API. And you'll see, again, as I talked about, our endpoint for that you create is from API Gateway. That's where you're going to create your REST API. API Gateway has a cache to ensure that these are very quick calls to your API. And then we have CloudWatch monitoring, so if anything goes wrong, you want to see what someone did, what call failed, you can literally quickly look at that and change it on the dime so the next call can be accurate. So you could actually look at the CloudWatch monitoring. What's great about this is real time. You can actually see what's happening and then respond. Now, what's we were talking about the agility of microservices, that all that compute power, I can determine the right tool for the job. So if you look at this infrastructure, this picture of this infrastructure, I have one endpoint or one microservice leveraging EC2 with Elastic Beanstalk is how I deployed it. So I have the ability to use EC2 or ECS for that specific microservices call, and then have that go to a DynamoDB backend. This is again wholly contained. It has no dependencies on any other microservice that may be in the solution. The other microservice that's running as a part of the solution, however, is coming in from our REST API with API Gateway, but this one happens to be going to Lambda. And Lambda then is writing to DynamoDB as its own data store. And then I can have yet another microservice that's a part of the solution that's not writing or going to Lambda or ECS or EC2. I may be using some third-party server or tool or API, and that's a part of my solution. So I can have API Gateway still be under my control and call those third-party services as well. So this would make up my entire microservices architecture for this fictional solution that we have. But notice the agility and the ability to truly do, which is the principle we talk about, use the right tool for the right job. So let's talk about some of these principles of when you're building these microservices that you really need to think about and use if you're really going to embrace this whole microservices strategy. The first thing is what we've kind of been saying over and over again. Microservices only rely on each other's public API, not their databases, not their common shared libraries. You're not going to do any software coupling or data coupling at all. You really want to make sure that any entry point is going to come through that public API. So anything that's in the back end from that, you can control, and that creates agility for you to change, again, at the right time. This just simply, again, use the right tool for the right job. So looking at this principle from an architecture perspective, I might have microservice A and its public API talking to microservice B. And the way that it's going to talk is only through that public API. It's not going to talk to each other's database. Even if these microservices are in the same org, like we talked about Amazon Web Services, Vera Microservices, those teams may have conversations, but the only entry point to those microservices in these individual teams will be that public API. The key of this is that gives me the ability to then hide my data. So nope, I don't, even though Mackenzie's right on the other cube and I can throw darts at him, the only way I can access what he's working on for his microservice and his team is again through that public API. So no direct connection to your data at all. You're hiding your data, therefore you're also controlling your data, schemas and everything. So if that changes, guess what? It doesn't affect microservices A. And again, if you look at this, what's also great about it is I can have multiple versions. So I first release my public API, and your public API is a contract between your microservices and any consumer that's using it. So whether that's internal, whether that's external, anyone who's consuming your microservice through this public API, you kind of have established a contract with them. And these clients say, okay, once this is released, this is how I'm going to call your information in your public API. What if I want to change that? What you really need to think about in doing this is, one, you need to support backward compatibility, but then think about the semantics of how you version things. So now let's say I want to have a different version of my store restaurant API. I'm still going to support the clients that are calling that API using the ID, the name, and cuisine. But then I may have some changes where I'm simply adding more features of things that can get more granular to call. One, I'm still supporting the legacy, but then this is a minor version. I'm not ripping out the guts, I'm not changing a lot of things, I'm really more adding functionality. So from a semantic perspective, this is just a minor change. So you see I would just do a version. This is store version 1.1 that has other things added, but again, I'm still supporting that client that is using the original API. And then I can then go to, hey, I want to release version 2.0. This is more of a dramatic change. So I can literally version this where some clients can still use the 1.x versions of it, but new clients that come on can then use the new 2.0. I'm still supporting my clients. I can version this very easy, leveraging AWS, and I still have agility here. So if you think about how you want to version your microservices, and it is a really good thing to do, one, involve your API in a backward compatibility mode. Make sure you're supporting those clients that are tying to you. Two, evolve your API so people know that this is a major change. So if I want to migrate from 1.0 to 2.0, what does that look like? I still have to support the 1.0. And again, this is very simplistic to do if you really implement your microservices strategy correctly. The second principle of microservices, we've been saying this whole time, but again, what does that look like? Using the right tool for the right job. Well, if you have talked about microservices or looked at microservices, even if you haven't implemented it, you've heard this term of a polyglot persistence. What does that mean? That's a great word, but what does that really mean? That means that in my microservices B, I could use DynamoDB and also have Amazon Elasticsearch because microservices B, that's what I want to use for it. But then I can change that database at any time because now I need to leverage a relational database. Again, guess what? None of my clients are affected by that, but I decide that instead of using DynamoDB, I'm going to change and use RDS and Aurora because it's the best database or data storage for this job. You can then therefore make these changes using the right tools without affecting your clients. Again, polyglot persistence, a great word, but really embrace that so you're using that right tool for the right job. And my developers for Microservice B decided, hey, the best way to develop against these is to use Java. And so I can decide for Microservices B at this time, Java with Aurora and Elasticsearch are the right tools for this job. In changing Microservices B, let's say I got a 2.0 version, I find that the enhancements we want to make are now best for me to use Node. I can simply and quickly and easily have a total separate creation developers working on Node for my microservices. Again, I still have yet to affect the clients, but I'm using the right tool for the right job to make my microservice as efficient and effective as possible. So the agility part of having a microservice allows me to then therefore quickly change languages, change data stores, change resources that I'm leveraging to create microservice B, one without affecting the client, but using the right tool for the right job.
I think that's a good time for a commercial break. Let's pitch that today at 1:45. We're doing a workshop where we'll actually build a completely serverless microservice, and what you'll be doing hands-on, step-by-step through various AWS services, including Lambda, DynamoDB, API Gateway, is building this. It is a restaurant lookup service, and this is the general architecture that you'll be playing with. So if you're interested and curious about serverless, about these services, and building one, within that 45-minute workshop, you'll have one up and going, so you too can store your favorite restaurants at home on your own service. Let's dive into the last few principles. Security, that's obviously very, very important. With Amazon, security is the first and most important thing for us. It should be for your organization no matter what you're building. It's much easier to implement good security from the start than to retroactively go back and try to secure something. So as you're building these services, there's a lot to consider. The first is defense in depth. And what we mean by that is there are different layers that you can implement for security, right? So with AWS, there's ways to do it at the network level. You can do that through security groups. You can think of security groups as kind of a much more intuitive way to do IP tables. From there, you have security you can implement on the container level, on the application level, and then through identity access management policies, which is on the user level. So in a combination of adding security at all these different points, you layer a good amount of protection on top of your service. There's also the idea of a gateway or a front door. By doing, you can think of a gateway is letting you in through a fence to a restricted area. That's what we talk about. That's what we mean by mentioning kind of a front door. If you have one point of access, you have to worry about securing that one entry point instead of having lots of stuff exposed and trying to constantly build up more fences. We've all seen Walking Dead. That fences don't hold up to zombie hordes. That's the same thing here. You want to have a good defense and a good gateway that you're protecting. API throttling. I guarantee if you have a very useful API that you launch and you make it publicly available, there is a university student somewhere who for their side project is going to start hammering it and pulling out 10,000 requests a minute trying to pull this info. Being able to API throttle is very, very essential in kind of reducing those high frequency requests to allow an even distribution of users who are using your site.
And cost.
And costs, yes. So you can do that through authentication, right? You don't want to just have, in most cases, a public API that anyone can hit, because then you can't identify who's hitting you other than just using an IP address. And IP addresses are really shared. If you think about a college campus, you want to identify individual users. We offer a lot of different ways to do that. We also offer custom authenticators. So you can do things like JWT tokens or OAuth 2.0. It's up to you. The last piece is secret management. So if you have S3 buckets, for example, we have a key management service. This will let you individually encrypt every file you store on S3 with a different key automatically for you. This is a very easy way to secure and encrypt your files. You just hit a checkbox. IAM will really give you granular control over which users have access to which resources. This doesn't talk about Cognito, but that's also a very good offering that will give you a service. Every time a request comes into a service, that service has an instance that now is granted certain access to resources within your environment. We have lots of ways to do good security, so please do it. I'm also personally a huge fan of HashiCorp's Vault. You do a lot of cool things with that. Definitely take a look at it. Things like single-use one-time passwords and more.
Can I add one thing before
Please
you? So
do.
when we talk about the gateway API throttling, like you said, there's going to be that one guy who's just going to hammer your API. What's also cool about what this provides for you as far as security perspective, you actually can generate also keys. So if you do have some legitimate business partner that needs that high scale of access to your API, you literally can create with API Gateway a specific key that they use to enter the rest of the API. This is a test if I can talk through, right? You can actually use that from a perspective of you can give them a key and then they may not have the throttle limitations that any other public person then therefore can use. So again, there's a lot of ability here to really make sure you're satisfying the needs of your customers. So when we talk about API throttling, you have complete control about who you can or cannot throttle or who you desire to throttle. Okay, go ahead, sorry.
I feel like the ringtone added
I
some good feeling behind it. It really
I had
helped
the
with the message.
soundtrack of the talk. That's what it was.
Fourth principle is be a good citizen within the ecosystem. That's a really weird title. What we mean by this is you have different APIs that are being now leveraged by different teams within your company. If you just start hammering someone else's API without telling them that you're going to be launching something, it makes it very difficult for them to kind of be aware of this traffic that's coming inbound. So it's also very good for them, for you to ask and say, look, I need access to this service. I'm rendering a page and we have to render this page in less than 500 milliseconds. So my SLA is I'm expecting this response to come back in a certain amount of time. You can establish those with your teams and it makes it much easier on everybody. For example, if you weren't building this with something like API Gateway, which lets you scale very easily and handle trillions of requests, then potentially you only cap out at 100 transactions per second, and suddenly 3 new services launch, start hammering that service, and take things down. So it's important just to be polite and say, look, I'm building on this, I'm not depending on your service, and this is the type of SLA I'm expecting out of what you've built. In addition to being a good citizen, it's very important to share your metrics with your other teams, right? You want to be able to let people see what the average request time is, or time to first byte. How long is your API taking for everyone else to hit it? This will eliminate situations where teams go, my service is broken because it's calling yours and yours took too long to respond. If this is available and published in a shared dashboard, it provides that transparency across your organization. You also want to have really good detailed logging and kind of metrics throughout that. Some really great open source tools, Zipkin. This will let you trace a transaction through every function call, right? So if you have 15 different functions within your piece of code, they're calling different backend resources, this will trace through exactly how long each one of those takes, and it'll give you the total timeline for that application to run. So if you start to see performance issues, you can detect that. Because there's a lot of backend dependencies, right? Your application may be able to support a lot of requests, but there could be a database that starts, because of a poor index, could start impacting performance. So being able to spot that quickly with these types of tools is very, very helpful. There's also a huge, enormous partner ecosystem. So tools like New Relic or Datadog, App Dynamics will help you dig into those metrics very, very easily. This is all great. This is all a talk about technology perspective, but just going into a company and saying, we should be doing microservices is not going to get you anywhere, right? You can't just say, we want to build this little thing and everybody else can use it. You really need a transformation from the organization to support it. And that's usually a big question people ask is, we want to start doing this, how do we encourage people to make this happen? Conways Law is pretty great. I'll let you read it. I don't want to read a slide. But let me kind of explain what this means. When companies grow, they build teams around technology, right? You end up getting a UI specialist team. You end up getting middleware, backend developers. You end up getting DBAs or data experts. And what you get is this big application. So if you have a change that wants to go through, you have to get all these teams and groups to kind of figure it out and approve those types of requests.
Herding cats.
It's a nightmare. But I also want to say this isn't bad in every case, right? If you're a 5-person team, microservices is absolute overkill. So be sure you're structuring teams to the appropriate size of your organization. You'll get to a point where you have 4 people in each one of these teams. Well, this doesn't make sense. You have enough capacity now in terms of development, or developer resources, to start restructuring this around products. Traditionally, in large companies, teams work on a project, then move on. When you think about microservices, you own the product, not the project. You own that product from the beginning, and you continue to work on that product to improve it. These small teams now mean that they can, again, create their small applications, and they can do these really, really well. These teams can, they'll manage their own, monitoring, they'll be alerted if something breaks, they'll work closely with customers, they'll understand how these individual components are leveraged by people so they can get better features and capabilities into those. If you think about a big monolith, trying to get that feedback from a customer into this massive piece of code is going to be very difficult. But if I just deal with shopping cart and they want a different way to view the shopping cart before I check out, well, I can quickly release that into this tiny piece of code and now it's available in the whole application. If you have not heard the 2 pizza philosophy, so at Amazon we do 2 pizza teams. That means it's a small enough team to feed 2 people or people on 2 pizzas. It roughly breaks out to about 8 people depending on how hungry they are. The important thing is if this team owns everything about their application, they're incentivized to make it better, right? In a large monolith, if I build something and just hand it over and I'm not getting paid for it, I don't care about the performance of it, I have no incentive to really make improvements on it. But here it's kind of like, it's our baby, we are very proud of how quickly our API responds, we're proud of the technology behind it, you really build a really healthy culture behind it. So full ownership, full accountability, you know if something breaks, what team is responsible for it. At Tumblr, we had a 3 a.m. rule, which meant if something broke, you want to build everything to where if it breaks at 3 a.m., you can very quickly understand what's breaking where and who's responsible for it. You shouldn't have to brew a pot of coffee and drink a bottle of whiskey to try to understand what's happening. It should be very clear. And smaller teams and make it modular like this makes that very easy to do. And again, it aligns incentives. It encourages people to not let services page.
Before you go off this page, you guys actually see this at Amazon and AWS with the products you consume. So for instance, we're talking about Compute and Lambda. That's a self-contained team, and they literally own every part of Lambda getting released. So when you go to the Lambda forums and you think you're just typing something in and some random person is actually answering you, those are people that are actually on that Lambda team that are responsible for helping you answer your question and to enhance the Lambda product. When you go on those forums or you go on these various things, you talk about the enhancements or the feature requests that you want to have with those. That actually goes back to those same people that are monitoring the forums, that created that dashboard, that actually created the product. So they have intimate knowledge of you as the customer, what you need, what's available, how they can solve it for you. So this, you actually see this process work in the products and the features and the services we release to you. This is exactly how those products and features get out the door and available to you.
And we're definitely not the only large enterprise that does this. People like Johnson & Johnson, like Nike, a lot of companies have adopted this to allow them to move much, much quicker. So great, let's hypothetically say that you've aligned your organization. You now are fully sold in the technology aspect of it. The underlying piece you still need to make that happen is automation. I don't need to tell you on why automation is important. I'm sure everybody understands why. But that means now these two pizza box teams can just release, drop it into this pipeline and get it out much quicker. If you were manually doing builds, manually doing testing, manually doing releasing, it's gonna increase the amount of time it takes to get those features out the door. So obviously, having a good CI/CD pipeline makes that possible. It's a very big overkill for a slide.
It is.
Oh, there's
I
one
wanted to
more.
make sure you knew that it was important.
And if you're starting fresh and you're looking to kind of build this, we have a lot of tools that makes this possible. 3 that you should take a look at. There's no meaning. There's 9511806. It's not a password. It's just a random amount of text that's snuck on there. But these are 3 tools.
It's definitely a password.
It's definitely a password somewhere. I just don't know which. But you're right. So AWS Code Commit is our code repository offering, so you can commit code into it. That integrates nicely into our code pipeline, which lets you do builds and tests. Once you have that artifact that's ready to go out, then Code Deploy will let you deploy that artifact out to your suite, or pardon me, your fleet. 5 years ago, it was very difficult to build a lot of this automation, right? That's why there's so many conferences around CI/CD. There's so many talks around it. But we've gotten to the point now where it's much, much easier to piece this stuff together to have a really streamlined infrastructure to make this happen. So I highly encourage you to look into these, and they integrate with these and many more services. I'm not going to read them all. You can see them all.
One last thing.
Yes.
The good thing about what you see about the code commit, the code pop, and the code deploy, obviously we have these services available to you, but we also integrate or also leverage current standards about what you want to use. So for instance, with code commit, you guys, everyone is familiar with Git, right? So guess what? You can leverage Git with code commit. It is built upon that premise of Git. So I do the same commands that I would do if I'm using any other repository for Git. If I want to integrate Jenkins into this build process, I can actually do that as a part of these tools. So at AWS, we want to again empower you to leverage this functionality in the way you work. And so our belief is that if you desire to use Jenkins or other standards, we allow you to do that with the services we provide. Summary.
Just take it away.
Good time. So the main thing that we want you to take away from our talk, and hopefully you'll join us in the workshop to actually get hands-on and doing this yourself, is microservices is a journey. You're really don't expect that you're gonna swing this magic hammer and everything is going to be perfect. Just like what we went through in migrating our monolith to microservices, we went down a journey that has taken a couple of years to have us enhance and refine to make sure we're providing the greatest services for you guys. So that journey will encompass a couple of things. You really need to take the time, and people never think about this when you talk about microservices, it's all about the technology, but you have to first understand your business domains. To be able to create a microservice, you need to understand those domains so you can understand what this microservice team, this microservice functionality will have. Another thing that you need to really think about when you're creating a microservice is that most people don't think about is there is a level of complexity with this. It's a complexity of testing, it's a complexity of architecture, it's a complexity of deploying. My uncle used to say, how do you eat an elephant? It's one bite at a time. And you need to realize that's the journey that you're encountering when you deal with microservices. So once you understand your business domain, you're really going to take a one chunk at a time. How am I automating this process for this microservice? What are the best practices I'm getting for this automating? What's the best tools to use for these types of microservices? Really, a relational database is really great for this one, but maybe a NoSQL is the better for this one. And those individual two pizza teams, let's use the term, will be able to make the best decision about that. And the reason they will, because they will have intimate knowledge as they go through this journey with each other for this specific microservice.
Fun fact about this slide, this little green dot right here, that's the S3 team.
Yeah, and I have a bridge to sell you. Okay, so remember, if you take almost nothing away, that the microservice is not just a technological strategy. It is also a cultural transformation. You literally are having to change the way your culture thinks when it comes to responding, building, and creating services. And that can be a huge challenge. So remember, it is a journey in building microservices, but if it is the right journey for you, so like you said, microservices is not right for every organization, but if it is right for you, that journey will be rewarding. So let's just kind of sum up these principles to take it away from you. I won't read the slides, you kind of get it, but remember, public APIs, only one access point in, use the right tool for the right job, that's going to be essentially important. Security, and smart security. Make sure you're securing it at the key levels. We want you to be a good citizen within the ecosystem. Not only will the ecosystem love you, but your clients will as well. And remember, again, this is a cultural transformation as well as a technology one. And finally, automate everything. Think about adopt an automation strategy and really look at how you can automate things to make this not only smoother to get those products out, more efficient and faster, and to this point, and cost effective. Cost effective is good. So the benefits, if I'm going through kind of these, at Microsoft we have this practice of saying the 5 whys, asking why to get to the root causes of a problem, and we kind of identified it. So you want to identify the problem, and the benefits will be, once you identify it, what is this going to do for me? Is it going to make this easier to scale? That should be one of the premise. Is it going to increase my release cycle and make it more efficient? Do I have a clear line of sight of who's accountable, who owns this microservice? The second benefit, again, asking the 5 whys that we do, is this easier to maintain and evolve the system? Can I get more features out? Can I accommodate customer requests more easily? How long do releases take? Is it minutes? Is it hours? That's really important if you're, again, enhancing this. And is it a short time period from the point that you took a customer request or took an opportunity to look at a new feature request to get that out the door? The key things you want to think about is this making me more agile? Am I faster innovating for my customers, my clients, and my business? And then am I really, and I told you Amazon is really big about being customer obsessed. We like to, like we say, delight customers. Are we delighting you? Are we making your lives easier? And if we're not, that means we have still a job to do. And so that's kind of the 5 whys of the root causes of issues, but these benefits came out of identifying those root causes and asking those 5 whys, are we actually solving those problems for you? This is the eye chart, 5 minutes, but guess what? I'm on my last slide, so I'm on time. Additional resources that you have. This is a lot, so we'll definitely make sure we publish this deck, because I know you like the links. I can't click that from there. But we have lots of examples, architectures, samples, blog posts, code out there for you to help you to start your microservices journey. We have serverless microservices talks. We have ECS examples. You guys can start today, and if you want information about how to do this, we have it available. Anything from your automation strategy to building your first microservice to looking at how others are doing. And if you really want to do something cool and you just, hey, you have cycles where I'm going to just dig in, it's really a fun lab, and we actually publish it now to GitHub. You can go through you can fight zombies and go through our zombie apocalypse lab. We had some events where we actually built a complete serverless microservice and a chat application that had these various microservices, including with the IoT device that had the motion of the zombies. So if you really want to get into some stuff, you can, and you got into this microservice strategy and you want to take it to the next level, there's a lab for you. It integrates with third-party tools like Twilio and things of that nature. But please come visit us for our hands-on lab. I think you'll enjoy getting your feet wet. And with that, we thank you, and please tweet us, reach out to us. We would love to hear from you guys on how we can help you to go down this microservice strategy. Thanks.
Any questions? Yes.
Do you use those open source tools internally?
Do we? Absolutely. We have a lot of open source. Also, is a good spot to go to is AWS Labs, which we share a lot of the stuff that we build and work on. But absolutely, we're heavily relying on open source.
What's cool about it is you follow, like, for instance, Werner and somebody on Twitter, you'll find there'll be open source tools that are totally not within our control, but he'll tweet about it, something that's cool. Like, you know, the serverless framework that's out there, we had nothing to do with that. That was a startup that created that, and that's a great framework. But you'll see us promoting it and talking about it because it's an open source tool that's making people's lives easier using serverless. Claudia.js is one that actually now ties into our new serverless Express framework. If you want to spin up one of your services and leverage that with the Node.js Express framework, well, Claudia.js had a way to quickly implement that. You'll see us tweeting about that. Go language and stuff. So all these open source things, we actually eat our own dog food. We actually do love open source. We actually look to use those things as they are efficient for us. Yep.
All right, does AWS code deploy work in a hybrid cloud that will deploy it outside to the company's data center?
Okay, so yes and no. You have some parameters to do that. We're gonna talk about that on the side because I want to know more information, okay? So yes, but I need to get you very granular in that question to answer. Any other questions? We don't bite usually, so. All right.
You get to play with this stuff later.
I told them,
Yeah,
play with
Yeah,
us,
sure
build
you
some
did.
stuff, yeah.
Reinforcement. Just because of this, scheduled almost as normal, we're just a bit late. The next talk is in here. I'm sorry.
No, you're good. We finished on time.
First of all, give him a big.